Uh, okay. It's working. Yeah. Okay, fine. Hello, everybody. Um, yeah, I'm just glad to be here. I just want to thanks for the invitation to speak here today. And yeah, just before starting, I want to share you things that we were speaking before yesterday night. It is about the presentation. Yes, I will speak about additive manufacturing in general. Um, I mean, the production with additive manufacturing. But yeah, last week was my vacation, and so I was trying not to think about the presentation. But at the same way, something came to my mind, and so I switched my point of view of the presentation. So I will start with the first part that I'm trying to share a sort of point of view, and then I will try to share something that we have done in past, some projects, some stuff that we are trying to do in this period. And so the thing is that um, for me was yeah, a great things to be here just because we know I will speak about PuntoZero later, but it is an opportunity to speak about our companies. And but at the same time, I was feeling another sensation to share with you also a point of view, to understand, to start a conversation, to understand what would be the future of additive manufacturing or the additive manufacturing production. And so, yeah, hello again. I'm Francesco Leonardi, and I'm one of the co-founder of PuntoZero. Um, PuntoZero actually is known for doing design for additive manufacturing, but I will speak better about PuntoZero later. So, yeah, I was speaking about this kind of feeling, the sensation. So the second responsibility that I was feeling is trying to share this point of view. And why I'm thinking about that is because I believe that the additive manufacturing technologies is the real technology that could change our future as a human being in general. So I believe that we are at a point right now that the technologies, the software, the material are at a very interesting level, at a very high level. And so at the same time, I'm feeling also that there are a lot of people that thinking that additive manufacturing is not the right technology for doing production, is not reliable, is so expensive. Yeah, there are so many problems, but probably also if you're working in the sector, are you thinking that the exploitation of the technology is not at the maximum point yet? So why is that? There are limitations, yes, for sure, but I don't think this is the problem. And which could be the right path to really exploit the additive manufacturing, really take the advantages of additive manufacturing. So for us is the first idea, the basic idea is going more and more toward the production. And if you think about some years ago, right now, I feel, at least is my personal feeling, but it's kind of changing. But some years ago, if you go to a trade show or if you speak about a new technology, everything was like, this new technology has so many advantages, is so rapid, you can do mass customization, you have freedom of design, etc. A lot of things that we already know. But I'm used to, when I do kind of presentation, to speak about this kind of things, just to make everything clear that they are not advantages, but they are just opportunities. And as potential is not the power, you need to find a way to transform the opportunities into advantages. So just thinking about mass customization, as I was saying before, some years ago was something really, really complex to do, almost impossible to do. Right now, we have software that we enable us also to do this kind of design process. And yeah, thinking about even this example, for example, again, mass customization. We are thinking about doing things customized for each person or yeah, stuff like that. But we are already thinking about not just the opportunity that the technology could give, but also about everything around the technology could give us. So if you think about, for example, we were speaking about the software. So this is an opportunity opened by the software and the technology together. So this is the real direction. I believe that everything around the technology could give the opportunity. And if we want to try to have more advantages, we need to find more opportunity. You need to create more opportunities from everything that is around that. So the idea is, yes, we go to proto, to product, and product because they are not just component, they are for prototyping, for doing rapid prototyping, because you are trying to use, you're exploiting part of the potential of the technology, but not all the part of the technologies. So I just show some of the product here. Yeah, absolutely, they are in polymer. But we saw so many lattice structures, so many components that are already improving performances in general. But actually here, even with the Adidas, we know that there is the lattice structure that is trying to change for giving you mechanical behaviors, new mechanical behaviors. Not the properties still the same, the material is still the same, but mechanical behaviors. Again, also other things. It is also interesting how luxury brands start to use that. So there are many different things that start to changing. So yeah, I was speaking about opportunities and advantages, and yeah, we are start speaking about also what we are trying to do in PuntoZero. And yes, for sure, for us it's trivial, but if you want to go from opportunity, balance everything and design it, yeah, for sure you have to use the design for additive manufacturing concept. But yeah, design for additive manufacturing has a lot of different meanings. If you search on the web, you can find different definition of it. But yeah, for us is something I was speaking before. If you want to create new opportunities, if you want to really exploit the technology, you have to connect all the points around the technology with the software, with the cloud computing we were speaking before, with how you manage to do something, how to create a new engineering concept around that. So for us, the design for additive manufacturing is trying to create a new kind of approach at the technology, and it's not just doing the design for manufacturing, no? The classical thing that you have a component, you just change you change the design for doing the production. But it's something more more open to understand the possibility that are around the technologies. So I'm an engineer, yeah, and so approach for me is, yeah, something is an idea, but is something really complex to understand in terms of numbers or way of working. And so if you ask me what PuntoZero is trying to do is not just design for additive manufacturing, but is trying to create methodologies to reach the goal every time. A methodology is something like a recipe, but instead of a recipe is not so strict, it could be dynamic. And so the method is the way you are trying to achieve your goal time over time. And this, and I believe this is one of the things really helps to go to the production. So last things before showing some project in general. Yes, so we believe that additive manufacturing is the technology for the present, but even for the future. Yes, if you want to fully exploit the technology, you have to pass from opportunities to advantages, and you use design for additive manufacturing as a new kind of approach to really exploit and really create new advantages in the future for this technology. But for us, there is one thing more, that is the natural inspiration. Yeah, I know that biomimicry is not a new thing, but I'm speaking about more in another kind of approach. So it is more like taking from nature not just mechanism, not just shapes, but also how they interact together. So we were speaking about a sort of ecosystem before. Even here we can find some new opportunities. Before I was hearing also about aggregation of component or topology optimization of things. Yeah, nature has always been the go-to for engineers and scientists. So I think also we are at the level that we are trying, as an engineer, we always optimize things in a deterministic way. So we are start working in a direction that we really optimize with loop, iteration, generative design, and concept like that. We really can deliver things that could be nature, could beat nature in the optimization process. But yeah, maybe this is the future. So yeah, PuntoZero is working, is like a sort of consultancy company. It's quite new. And we are based in Italy, in Milan. And we do design for additive manufacturing, yes, for sure. But we create this method, and we try to have always a R&D project and stuff, internal stuff, to try to push the boundary of design for additive manufacturing in general, and try to create methodologies for production. So understand which type of lattice structures, if you want, I don't know, matte finish on something, and you have, for example, a post-process that is really shiny, you can be able to balance everything to have another things. So it's like changing the mechanical properties, but here is just visual things. So this was one of the first projects that we have done in the past. I will not speak about everything around that, but we were using two material here, so one rigid and one soft. And so a part of that project was, the idea was the interchangeability of some components. And so from here we start looking at nature and looking about also things that are already be done, like Velcro stuff. And so we take the inspiration, we start from them, and we start using the gyroid structures. Gyroids everywhere. And so with the gyroid structure, we had this opportunity to really change, gyroid structure are TPMS structures, so they are fully driven by math, designed by math. So this is a big opportunity because you can tune the structure as you want in each point of the 3D space. So we created that structure that is driven by field and was like modified with vectors. And so if you see in the part, you can see this part, this part of the gyroid that are not the same of the classical gyroid. I mean, with this vector field manipulation, we have done something that was alternating. So we have a sort of, like Velcro, they worked with hooks and pins. And so this gyroid structure was just a part of the two part of the interchangeabilities. And with this manipulation, we had this kind of new kind of modified gyroid. And so with this parameter, we have few parameters for changing the density, for changing the shapes, for changing the fit that was creating at the top. And so since everything is driven by math, we are also able to shape this kind of things around every different shapes, independently about the complex of the geometry. So again, if you see the part that I was showing before, you can see that this part is completely conformal to a curved surface. So yeah, the idea around that is, okay, what we can do is just Velcro things. No, the idea is that you can do this kind of structures as a surface structures. And so you can do in different type of material. You can have like rigid with rigid or rigid with soft, soft with soft. And also think about if we have this kind of component and we can print in metal or in ceramics. We can open new opportunities for doing new kind of stuff in aerospace or in medical, or even if you have to, I don't know, combine metal with composite. You can use that for like an interchange, like a mechanism to bond together. And even if you want like two different components, one rigid and one soft, you can remove glue in the future maybe. So this could be something to think about. And yeah, this is another project that we have done also in the past. It is a component that we have done for this crazy pilot in Italy. And we work on this part that is actually the linkage of the motorbike. And I know there are lattice structure, is a motorcycle for cross things and stuff like that. So it doesn't seem so clever to do lattice structure there. But in a minute, I will explain why. So for these things, we had an idea on workflows in general. So as I said before, we also creating methodologies to optimize things. So before they were speaking about topology optimization. So you know that if you start with the topology optimization, you have a design space, you probably want to reduce weight, but you are trying to stay in the same level for the stiffness. If you want to do another things to evolve the component, if you want more a component that is stiffer, but at the same time is lighter, is something that you will not do with topology optimization. So the idea is, let's try to use, we have created a more complex path and workflow, but the focus point is that we have used the classical algorithm for the topology optimization. So we use the classical stress distribution of von Mises. And we have done in the first step the opposite things you normally do with topology optimization. So instead of removing material where the density is going to 0, we add material where the density was trying to be more than 1. And so with this idea and with this kind of loop that we have done, after that we have a new design space. With this new design space driven by field-driven design and with topology optimization, we done another topology optimization on this field. And so we had also the lattice structures that it was like the gradient between the densities. And why that? I will explain why, but these are the number that we have achieved with this kind of workflow. So they are actually lighter, but they are also more stiff compared to the first one. And I'm speaking about this one because we are trying to improve the workflow also with some concept of changing the shapes, not just removing or adding material. And that is, the final goal. We have done static analysis on it and everything passed. And we are doing fatigue tests because we were also trying to use a new kind of powder on this component, really close to the scalm alloy things. And why we are doing also lattices. Lattice here, we have used that just a concept. So you can see also that all the component is really, really rough. Maybe here. Okay. The component is really, really rough. It seems not finished. It seems not designed in a correct way. That is the external part, the new design space I was trying to explain before. So we leave that just to make understand the concept around that. And the same thing is also for the lattice structures. The lattice structures, because the idea is in the future, in the future we can use lattice structure not just to doing structural things, on this side. So not just for structural things, but also as a sort of an additional component that is, I don't know, if you're using a very light material, very optimized things, you can maybe want a sort of, I don't know in English, sorry, but a sort of supplemental structure that saying to you when could be a fractures. So the lattice structure will be something that could be around some component, could be where there is the max stress distribution, and just to be aware when some crack is coming to happen in the future. This is the last things. This is a product. It's not a product on the market, but we have developed this kind of mask with in collaboration with this company. That is a company that is doing glasses and masks for, big brand in sports. And the idea around that was that, the classical mask is done with different components. So there is lens, there is the strap, yeah, absolutely. But then there is the frame, the tissue around that, the foam, the gluing part. And so the idea was let's try to do everything in one component. Absolutely, the lens and the strap still the same, but everything has the frame, the foam, the contact part of the skin, the frame also for the strap, is everything inside this component. So, if we start from the outside, we have created this kind of geometry that again takes inspiration from nature, and it takes inspiration from the natural effect that the lotus has. So we have done some iteration, even because you have to change the geometry and the distribution of this hole, but also because we need also for this component doing a post-processing things. So with the post-process, you're changing the shapes of the holes. So we have created this kind of holes that are taking the breathability, that is one good things you can achieve with additive manufacturing in general. But at the same time, the liquid are not coming inside. And if you see the part, you can see that the distribution, maybe is not so visible here, but the distribution is slightly changing during this kind of part, the contact part with the skin. And if you see on the inside, there is kind of lamellar things. The lamellar things, again, are gyroid structures. And the gyroid structures are, we have done some kind of design of exploration just in order to tweak the properties, the mechanical properties of the gyroid structures to have different kind of density foam. So you are actually able to stretch the geometry, to have a gradient on the thickness of the part, but even on the stretching part of the gyroid, in order to have different response of this skin, of the foam that is created inside the mask. And yeah, this is also done because when you do a product that have to be really, it is going to be in production, you also need to manage the complexity of the post-process, the powderability. And so, yeah, that is the real tough part. And yeah, this was almost the workflow that we have used. And so this is the component that we have finished that like 3 months ago. It is for my presentation. Thanks also to be here. If you have any question, I will be glad to help respond in that.